Okay, good morning, everyone. My name is Tesfaye Bedane. I am a postdoc researcher at the UCD School of Agriculture and Food Science. Today, I will be talking about the impact of domestic and commercial electro-heating on quality parameters of cooked beef meat. Next slide, please. As you may all know, in domestic cooking and in the food processing industry, heating treatment is applied to foods not only for inducing the desired chemical and physical changes associated with cooking, but also to inactivate microorganisms and the enzymes. Traditionally, as you can see in the picture, cooking of meat and a meat product is predominantly carried out using conventional systems which are more based on convective and conductive heat transfer methods. However, these methods are associated with long processing time, high energy consumption, as well as non-uniform heating. Recently, emerging technologies, as Jim explained previously, which are applied directly to a food product and give rise to volumetric heating, have received considerable attention in reducing the drawbacks I mentioned earlier. So the objective of this work was to investigate the impact of domestic e-cooker, which I will explain later, and the commercial MEF technology on physicochemical quality attributes of beef meat, compared to, of course, the conventional control. Next slide, please. So in this experiment, beef meat samples of 2 centimeter thickness were cooked from a refrigerator temperature to a target temperature of 72 degrees Celsius at the core and held at this temperature for 2 minutes prior to cooling for analysis. Samples were cooked in a Nutri-Pulse e-cooker and a batch moderate electric field systems using 1 kilowatt power in a 0.5% saline solution, and results were compared with conventional cooking in water bath at 80 degrees Celsius. The Nutri-Pulse e-cooker used for this study was a domestic electro-heating appliance, which is developed by IXL Netherlands, which use electric field in the form of DC to smartly cook food products. It can be controlled through tablets. The moderate electric field system which we have in our lab is a commercial electro-heating system upgraded in our lab, which use electric field in the form of AC and has the capability to deliver fixed power. Next slide, please. So to show you some results, domestic e-cooker and commercial MEF systems significantly reduced heating time to target temperature of 72 by about 87% and 90% respectively, which also significantly reduced the energy consumption. As you can see in the spider diagram, texture profile analysis indicated that there was a similar level of tenderness among the treatments. Cooking loss also significantly reduced while sufficiently delivered appropriate inactivation of the target pathogen. Overall, this study has shown the potential of using the domestic e-cooker and commercial MEF technology for rapid and uniform cooking without adverse effect on the quality attributes. Of course, further work on sensorial properties and the availability of nutrients is required to more strengthen this work. Next slide, please. And thank you for your attention.